Good evening, sir.
Yeah, good evening, Abhinav. Let's see.
देखो ये बस यहाँ पे ऐसे लिखा है देखो यहाँ पे डार्क नहीं हुआ है देखो डार्क नहीं हुआ है अदरवाइज तो कैसे मैं सरकारी में पाता हूँ
Okay, so we will continue with the metals and non-metals. In the last class, we had done metallurgy,
Good
and in
evening, sir.
that today, good evening. So today we have to
Good evening,
finish
sir.
the chapter with electrolytic refining. Okay, so that's the part we'll be doing today. We'll do electrolytic refining. All right. So just let everyone join. Give me just 1 minute for everyone to join. Hello, very confused.
Good evening, sir.
Yeah, good evening. Okay, so let's continue. So in metals, we had to do corrosion. All right, corrosion was left, and one more topic was left after corrosion. Perfect. All right. Right. So this is what we had done, and today we have to do just electrolytic refining and corrosion. These are the two topics which are left. So here in this case, you see we are doing the electrolytic refining of copper. To see how does electrolytic refining of copper can be done. So Sumukh,
Yes, sir.
how do we obtain copper?
By refining.
By refining. No, from the extraction process, can you explain how do we obtain copper? Anyone? Abhinav, can you tell how can we obtain
Process
copper?
through the process of smelting.
Smelting? No. Okay,
Sir,
is the
sir, sir, sir.
copper
Electrolysis, the process of electrolysis.
okay? Is the copper high reactive or low reactive?
High react,
This
low reactive.
medium reactive.
Low reactive, high reactive, or medium reactive?
Medium.
Medium.
Copper is a low reactive metal. It comes under the low reactive metals. So copper is generally extracted from copper glands. Okay, the ore of copper is copper glands, right? So from the copper glass, by the process of roasting, we are able to obtain copper. Okay, once we obtain copper, then that copper which we obtain, it still contains some of the impurities. So to remove those impurities and to obtain a approximately 100% pure copper, we do this process of electrolytic refining. So see, this is not electrolysis. This process is electrolytic refining. Okay, do you know anything about extraction of aluminium?
No, sir.
The aluminium was extracted. Okay, so aluminium was extracted by earlier when the process of electrolysis was not determined. So earlier the aluminium was extracted by the process of which we called over there as uh, we studied in displacement reactions. Okay, so aluminium was obtained by the process of displacement reaction and it was very hard to obtain. Okay, so aluminium, whatever aluminium we got over there, that aluminium was very less since it was hard to obtain by the by the displacement reaction. Okay, so it was hard. Then later on, this process was discovered. This process was invented, and by this process we can obtain aluminium. So when we use this process of extraction, electrolytic refining, okay, so the cost of aluminium dropped. Initially, the cost of aluminium was very high. So later on, the cost of aluminium it dropped, right? Right. See, electrolytic refining of copper. For the electrolytic refining of copper, we take here a copper vessel. Sorry, we take a vessel in which we keep a salt of copper. So to start with, we take a glass vessel, and in this glass vessel, we consider two electrodes. Right? So here we consider two electrodes. One made up with pure copper, the other one made with an impure copper. So we consider here the two electrodes and the solution here or the electrolyte here it consists of a salt of copper. So it can be copper sulfate, okay, or any other salt of copper is taken here as an electrolyte. So any salt of copper can be taken here as an electrolyte. So what are the substances that we take here? This one is our copper sulfate solution which we have taken. So if you want to purify aluminium, you will take a salt of
Sir, did you
aluminium.
call me?
Yeah?
Sir, did you call me?
No. I didn't call anyone.
Yes, sir.
So but still I would like if everyone's cameras are on. If you could keep your cameras on, that would be very much preferable. So suppose this one is your impure copper. I consider this as an impure copper. And this rod to be made up of pure copper. Now I connect them with the help of a battery. So see, to connect them with the help of a battery, I make the connections. And now it is to decide that which one will be made the electrode uh, as a positive electrode and which electrode will be made as the negative electrode. Right. So the impure copper electrode, we make it as a positive electrode. We also call it as the anode. So the impure one is made the anode or the positive electrode. The pure one is made the negative electrode. Now see, you clearly need to see how the process occurs. So in the solution, as you know that copper sulfate, we have taken here a solution of copper sulfate. Aryan, Sumuk,
Yes, sir.
please keep your cameras on. Siddhisri,
Yes, sir.
Siddhisri, will you be
Yes,
able to
sir.
respond today?
Yes, sir.
Okay. So here, which solution have we taken? Yes, Siddhisri, what solution have we taken? Shubhans, what is the solution that we have taken?
Sir, can you repeat?
What is the solution that we have taken here?
Sir, copper sulfate.
The copper sulfate. So what type, what all ions are present over here?
So copper and sulfide ions.
Yes. So when you consider a copper sulfate solution, so the copper sulfate solution, the copper sulfate solution, it gives us copper ions Cu2 plus, and it gives us the sulfate ion SO4 2 minus. Got it? So in the solution of copper sulfate, even if there are no copper rods, there is no electricity. So still you have copper ions and sulfate ions in the solution. Right. So you see here, there are some copper ions. So I'll make these copper ions to look like with these red symbols. So these are the copper ions which are present in the solution. Got it? And the solution also contains some of the sulfate ions. So see, let me. नहीं, ऐसा काम नहीं करना, सही वाला करो. Okay. So see this sulfate ions, they I have represented with this blue dot. Copper ions I have represented with these red dots. All right. So the solution contains a lot of copper ions and the sulfate ions. Now when I turn on the switch, when the two electrodes are connected with the electricity, so the two ions, they start moving. The copper 2 plus ions, they start traveling towards the negative electrode. Here we have the negative electrode. So they start traveling towards the negative electrode. Got it?
Excuse me, sir.
So the copper ions which are present over here, they start moving towards the negative electrode over here. So they start traveling here. The copper ions, they start traveling here. They start traveling over here. Now what they do at the negative electrode then. Okay, so let us see what happens at negative electrode. So at the negative electrode, you have the copper 2 plus ions. The Cu2 plus ions or the copper 2 plus ions, they gain 2 electrons from this. See, the battery is continuously supplying the electrons. The electrons are traveling through the wire. So this pure copper, it is having some electrons on it. So they are attracting the positive copper ions from the solution. The positive copper ions, they get attracted to these 2 electrons and hence get neutralized and form copper atoms. So neutral copper atoms, they are formed at the negative electrode and they stick to the electrode. All right. Then what about the neutrality of the solution? To maintain the neutrality of the solution, the positive charge of the battery or the positive terminal of the battery, it forces the copper atoms from this impure copper to move into the solution. So as soon as one of the copper ion gets deposited on this electrode, one of the copper ion from the impure electrode, it jumps into the solution. All right, so it's like this: a copper from an impure copper jumping out into the solution, and one copper ion moving from the solution into the negative electrode. Got it? So continuously the copper atoms from the impure copper, they are getting into the solution. All right. Continuously the copper atoms, they are getting out of this impure copper, they are getting into the solution. All right. So they are getting into the solution and this is becoming thinner and thinner. All the copper atoms which are there on the impure copper. So the impure copper anode, which we also called as anode over here, which is positively charged. So this is our anode. This is continuously losing the copper atoms. It is becoming thinner. All right. So everything from here it goes on. The impurities which are there, they do not move into the solution and they get deposited at the bottom of this. Okay, so when they get deposited here at the bottom, they are called as the anode mud. As they are deposited below the anode, so they are called as anode mud. Understood this? Understood the process? We know.
Yes.
Sorry, sir, that was a glitch.
So see, I have written what happens at the negative electrode. If I see at the positive electrode, see what happens at positive electrode. At the positive electrode, we observe that copper is moving into the solution. It is becoming Cu2 plus and donates 2 electrons. So the 2 electrons, they travel through the wire to the positive terminal of the battery. So in this way, you are able to purify copper. Okay, so let's see this through some video how the copper ions are moving. I'll try to see. Uh, let's see. Mhm. Okay. So here, can you see the copper atoms from the solution? You can see from the solution, copper ions, they are moving on to the negative electrode. They are getting deposited over here. The mud part, the anode mud or the impurities, they remain over here and they get deposited at the bottom. You can see the same thing over here, how it works. See, the copper ions, they are moving from the solution. See, the copper ion moving from the solution onto the negative electrode. The electrons being transferred from the negative terminal of the battery, making this electrode negative. When the copper atoms are deposited over here on the negative electrode, it becomes thicker. Can you see? Now it has become thicker. And here, what is happening at the anode? The impure copper. The copper atoms, they are getting into the solution. The impurities, they are getting deposited below it. And the electrons traveling through the wire to the positive terminal of the battery. Got it? Okay, and is this clear to everyone? Shall we move ahead now? Arav? Arav?
Yes, sir.
Daddy? Okay, so
Yes,
Arav,
sir. Yes.
Arav, what happens to the anode during the uh, progress of the reaction? What happens to anode?
Sir, don't know.
So then, when I was explaining, you should pay attention. What happens to the anode?
Yes, sir.
What happens to the anode
Mm-hmm.
during the progress of the reaction? What happens to the anode?
Sir,
Sir, it passes the
Hmm?
copper copper particles to the cathode.
It, it passes the copper atoms into the solution. It passes the copper atoms into the solution. Then what happens over there? The copper, the copper anode, it becomes thinner. Slowly and slowly it gets vanished. Okay, first it becomes thinner, then slowly and slowly it starts to vanish up. As all the copper atoms, they get into the solution and the impurities, they get deposited below. Okay. So Dhanshu, what is anode mud? Yes, Sudhanshu, what is anode mud? Are you there, Sudhanshu? Sudhanshu, are you there? Alright. Shubhansh, Shubhansh.
Yes, sir.
Okay, Shubhansh, what do we call to the impurities or what name is given to the impurities which get deposited below the anode?
Yes.
Yes. What name is given to the impurities which get deposited below the anode? Sumuk?
Sir,
Anode mud.
Anode mud. Alright. It's called as anode mud. Okay, what happens to the cathode during the progress of the reaction?
So the sulfide ions go there.
The
Sulfide ions.
sulfide ions, no.
Sir, it is completely like the electrode will not be there at the end of the reaction. And
The
all the copper will be at the anode side.
the cathode becomes thicker during the progress of the reaction. The cathode becomes thicker. Okay. So I just repeat this once more. What happens during this? So during this process, we make the impure copper to be the anode. We connect it with the positive terminal of the battery, and a pure copper electrode is made as the positive electrode. Okay. We take a salt solution of the metal which we are refining. So here we are refining copper. Hence we have taken a copper sulfate solution over it. We can take copper chloride also. So we can take any solution of copper over here. Right. So we have taken here copper sulfate as a solution. Then when electric current is passed through it, the positively charged copper ions they get deposited on the negatively charged negatively connected cathode. When one of the copper ion it gets deposited on the cathode, one of the copper atom from the impure anode it leaves the anode and gets dissolved in the solution. So slowly and slowly the particles of copper from the anode they start coming into the solution. Okay, so this causes anode to thin. This causes anode to become thinner in size, and the impurities which are there they get deposited at the bottom as anode mud. Alright. So by this process of electrolytic refining, we are able to obtain about 99.9% pure copper. So just see your text also. Anyone having any doubt here?
No, sir.
No.
No.
That's good. So see, electrolytic refining. The metals produced by various reduction process described above are not very pure. So they contain impurities which must be removed to obtain pure metal. So this is the most widely used method of refining impure metals, which is electrolytic refining. So here in this text, what you diagram you see, your anode is made over here and connected to the positive terminal. This one is the cathode connected to the negative terminal. Now see, it shows the flow of copper ions from the solution onto the cathode, as well as the copper ions, they are moving from anode into the solution. Alright. So the copper ions, they are moving from anode into the solution. Now, the last topic here, corrosion. So corrosion, it is the process of slow oxidation of metals. Slow oxidation of metals is called corrosion. Right? So slow oxidation of metals when exposed to air is called as corrosion. It makes the metal lose its luster. The metal start losing their luster. Sometimes we also start losing the metal. For example, we consider here uh, the corrosion of three metals has been here. Consider the corrosion of silver, corrosion of copper, and corrosion of iron. So when silver particles they are exposed to air, they react with sulfur present in the atmosphere. You see, corrosion, here we have shown three substances. Corrosion of silver, when silver is exposed to sulfur, it reacts with sulfur to form silver sulfide, which is black in color. So there is a coating of silver sulfide which is obtained on it, and because of this, the silver will lose its luster. It will lose its shine. Then about copper. So copper when exposed to air, it reacts with carbon dioxide to form copper carbonate. When it reacts with moist air, it forms copper carbonate. Got it? So copper reacts with carbon dioxide to form copper carbonate, which makes again the copper or provides the copper a green coating on the surface. So copper appears to be green because of the reaction with carbon dioxide from the atmosphere. A similar thing happens with iron, and the corrosion of iron is called as rusting. So iron reacts with atmospheric oxygen along with moisture to form rust. So this is Fe2O3 dot X molecules of H2O. So there can be any number of molecules of H2O. The molecules of H2O, they help in the formation of rust. So the conditions which are necessary for the formation of rust, it is the presence of oxygen and the presence of moisture. Both are required. Iron plus oxygen combining with water to form Fe2O3 dot XH2O. All these processes are corrosion. So what we can call corrosion, it is a process by which metals lose their luster when exposed to air. A specific name for the corrosion of iron is called as rusting. The product which is formed is called as a rust. Okay. So rust is a brown colored substance which is obtained on the surface of copper, on the surface of iron. When iron is exposed, okay. So any doubt to anyone up to here?
No, sir.
No, sir.
No. Okay. So we'll talk specially here for iron. See, here it shows iron here. This experiment has been performed for or to study the corrosion of iron. Alright. So see here, we have taken 3 test tubes, test tube A, test tube B, and test tube C. In the test tube A, water has been taken up and a space is there for air also. So you have a mixture of air and water. In the second test tube, you have taken water and water is filled such that the nails are dipped in it. The nails are completely dipped in the solution. Alright. So here nails are completely dipped in the solution. And in the last one, there is no water present. And even to remove any moisture present in this test tube, we have added anhydrous calcium chloride, which is a drying agent. So it will absorb the moisture that is present here. Right? So it absorbs all the moisture present here in this test tube. Got it? So you have calcium chloride and in this test tube B, you have put a layer of oil above water so that no air can or no oxygen can enter into water. Right? So we observe that there is no corrosion occurring in the test tube B and test tube C. But we observe here that the nail in test tube A it has got corroded, it has got rusted, it has a layer of brown colored rust on it. Okay, so this process explains here that rusting of iron, it requires necessary conditions. And what are the necessary conditions for rusting of iron? For rusting of iron, iron must be exposed to air and moisture both. When iron is exposed to air and moisture both, then rusting of iron can occur. Got it, everyone? So with this, I hope we have completed this chapter. We have
Yes, sir.
completed this chapter of chemistry. And you can do the prevention of corrosion. Of course, there are various methods like oiling, galvanizing, formation of the alloys. These are some of the methods by which you can prevent the rusting of iron. Got it? Okay. Bye all of you. See you again in next class. We'll practice some questions and the chapter will be.
Thank you, sir.
Bye.
Bye, sir.
Thank you, sir.
Thank you, sir.
Bye.